This is section 6, derivative rules, example 5. So now that you know how to take a derivative using the power rule and all of the various properties so far, we're going to find the equations of tangent lines. And you've actually already done that, right? It's the y minus y1 equals m times x minus x1. And it's always going to be in point-slope form. We don't have to change it into y equals mx plus b, your slope-intercept form. That's not necessary, ever, unless that's what the final answer looks like, in which case you have to know how to get there. But if it's on a free response question, and it does happen, you can just leave it in point-slope form. Now remember, to find the slope of the tangent line, you take the derivative, because the derivative is the slope of the tangent line. It's the instantaneous rate of change. So we've already been taking derivatives. All you have to do is make sure you plug in the point that corresponds to the correct equation that you need. So that's what we're going to do in example 5. Another thing you need to know is the terminology for the normal line. Now, a normal line is just the line that's perpendicular to the tangent line. So instead of saying it's the perpendicular line now, in calculus we use the term normal. And remember, the slope of a normal line in relation to the original line is 1 over the original slope and then the negation of that. So it's the opposite reciprocal. Okay, that's what you were taught when you took geometry. So we're going to do that. First, we have to take the derivative. So given this function, find the following. The derivative of 2x to the 5th power minus 3x squared is, we're going to take that 5, move it to the front. So we get 10x to the 4th power. We move the 2 to the front, so we get minus 6x. If I want to find f prime of negative 2, I'm going to take a negative 2 and plug it into the equation that I just got. So negative 2 squared is to the 4th power is 2, 4, 8, 16, times 10 is 160. And then negative 2 times negative 6 is positive 12. You add those together and get 172. The slope of the tangent line to the graph of f at the point 1, negative 1 means you're finding f prime of the x value, right? Because it's f prime of x. So it's the x value that's going to give you the slope, at least with this particular equation. So we're finding f prime of 1. Well, we already have the equation for f prime. It was 10x to the 4th minus 6x. So if I take 1 and plug it in, I get 10 minus 6, which is just 4, which means that the slope of the tangent line to the graph of f at the point 1, negative 1 is 4. Well, that makes writing the equation of the tangent line very simple, because it'll be y minus y1, right? But because it's negative, it'll be plus, so it'll be y minus y1, which was negative 1, equals the slope, which we found in part C, which is 4, and then x minus x1, which is the x value. And of course, that negative negative becomes positive. Oops, that's a 1. So that's the answer. Now, when we find the equation of the normal line, the slope of the normal line is going to be the opposite reciprocal of what we found in part C. The opposite would make it negative, the reciprocal would make it 1/4. But the rest of the equation is actually going to look exactly the same because we're going through the same point. The only difference is the slope. So we end up with y plus 1 equals negative 1/4 x minus 1.